Hi, this is our introduction video to parametric equations, something we did in pre-calc, so this is just going to be a quick review of what a parametric equation is. And we have something just in physics and science that says that the height of an object when you throw it up into the air can obey a certain property based on how fast you threw it up in the air and from what height you threw it up. All of these in terms of feet and seconds. So if you threw it, say, with a speed of 70 feet per second from a height of 5 feet, then the height of the object, the vertical position, the vertical position of that object would obey this equation, okay? Now, that's all well and good, but if you type this into your calculator in a function mode, you'll see something like this, but the x-axis here really represents time, and this represents height. So while this is the equation you're going to see, that doesn't really describe the path you see in space. That ball might be thrown something like this, it might be thrown behind, it might be thrown straight up in the air. The height will always be the same based on the time, but where it actually is located, we don't know. In order to know that, we would need more information. And so we need to introduce a second equation, something that would represent the horizontal position. And then if we put these two equations together, we'll have a better idea of what is happening. And so you can create a table, something like this, and we can plug values in for t and calculate things. So for example, if I put 0 in for t, we'll get 0 for this, we'll get 5 for that, and so we are at the point 0, 5 at initially at time 0. If we put 1 in for this, we'll get 15. If we put 1 in for here, we'll get 59. So 1559 is right here. So at time 1 second, we've moved up here. So in that 1 second, this ball traveled like this along this path here. Okay. Now we could keep doing this, find 2, find 3, find 4, find 5, and see how the ball travels along that path. And this would actually give us the actual distance, the actual position of that. Creating this table by hand is fine, but we can do this on the calculator much more easily. If we go to, if you go to mode, you'll see that FUNC, that's for function, but next to it PAR, that's for parametric. We click on that and hit Y equal. Now we'll have spaces for both X and Y. So I can type in 15, hit the variable button. The variable button now, instead of giving me an X, will give me a T. And I can do the same thing for here, negative 16 variable squared, plus 70X plus 5. And when I go to window, I can make this go for a certain amount of time. So I'm gonna have it go from 0 to 5 seconds by every 1/10 of a second. And my X is going to be my horizontal distance. I'll go out to say 100 feet to the right, and I'll go 100 feet up in the air. If I hit graph, there's the actual now path that this object is going to take. When I hit trace, I can put in any time I want. Let's say I put 3 seconds in, and at 3 seconds, this object is 45 feet to the horizontal and 71 feet up in the air. And as I move, I can see that object falling to the ground. And I can get more information now from this. Not only do I know where the object is, I know when it's at that position. All from just 2 little equations here. Right? So I get a little more information when we do parametric versus regular rectangular. So for something like this, we might quickly just go ahead and throw these times in for these. So for example, if I put -2 in here, I'll get 0 and -1. So 0, -1 would be right about there. That's where we're at time equal -2. If I put -1 in, I'm going to get -3, and I'll get -1/2. So -3, -1/2 is like right there. Okay. Put 0 in, I'm going to get -4, 0. So it'll be right there. Put in 1, I get -3, 1/2. So I get that. Put in 2, I'm going to get 0 and 1. So right about there. And then put 3 in, I'm going to get 5 and 1, 0.5. So I'm going to get something like that. So this object, or whatever we're describing, is going like that. And the arrows indicate the path we go on this. We started here and traveled up like that, right? Now, if we want to eliminate that parameter, say we want that, for whatever reason, want that parameter to go away, what we can do is solve for the parameter. So I could multiply by 2, and now t equals 2y. I can take that 2y and put that in for t, and I get x equals 2y squared minus 4. Eliminating the parameter just means let's make t go away. So the best way to do that is to solve for t and then plug it in for t in the other one, and now you've solved for it. Depending on what you need to do, maybe you have to do a little more solving there, but that's what they're asking for on that. Okay. A couple other little wrinkles or that we could do with this. Here is what we did in pre-calc. This would be an ellipse. It would have a horizontal axis length of 3. It would have a vertical axis length of 4. You would make those dots there, and with an ellipse, you would then draw your kind of oval path around there, okay? Not the hardest thing to do, but if it's not in this nice format where it's equal to 1 and all like that, it can be a little clunky to get into. So what I want to do is try to put this as a parametric. So we're going to introduce this idea that cosine squared plus sine squared equals 1. This is something familiar from our trig and pre-calc days. And since these are both squared and these are both squared, I could go ahead and let x over 3 equal cosine and y over 4 equal sine. And therefore x equals x equals 3 cosine theta and y equals 4 sine theta. Okay. Now what that allows us to do is then create our own little thing here. If I put 0 in for this, the cosine of 0 is 1, so this will be 3, and that'll be 0. This will then be 0, 4. Put pi and I get negative 3, 0. 3 pi over 2 gives me 0, negative 4, and then we're right back to 3, 0. So we start at 3, 0, go up to 0, 4, go to negative 3, 0, go down to 0, negative 4, and back. We go in this fashion here. It creates that ellipse. And so if I put it on the calculator like that, I can do 3 cosine of that, and let this one be 4 sine of that, right? And for my window, I'm gonna go from 0 to 2 pi, so that way we get to see the full circle. I'm gonna go by that to make it happen. And then I'm gonna go from negative 5 to 5, from negative 5 to 5, hit graph, and there's our ellipse. Okay. If for some reason we wanted to shorten that up, let's say we want to make that a little skinnier, instead of 3, I want that to be just 1. Now it makes a very skinny one. Instead of going all the way out to 3, it only went to the 1. Or if I want to make it a little bit bigger, I can make it go all the way out to 5. Again, I can control that with just a simple little change here, versus trying to do the big change in here and work it out that way. That would be a lot more difficult. Also, one of the nicer things about this is, let's say I make it skinnier, but I want to move it 2 spaces to the right. Simple enough, I just add 2, and now I've moved it over 2 spaces to the right. So I can have a lot of control in here about how it looks and graphs, which is what makes this parametric a little bit nicer for those kinds of equations. The last one that we're going to look at then is this. And again, when you say that sine squared, pardon me, plus cosine squared equals 1, if you wanted something else, let's say that we divide by cosine squared, and by dividing by cosine squared, we get tangent squared plus 1 equals secant squared. And if you subtract that, that gives us secant squared minus tangent squared equals 1, all right? So if you had x divided by 4 and y divided by 5, you could plug those in, and we would have x divided by 4 squared minus y divided by 5 squared equals 1. That's a hyperbola. So this right here, if you graph it, would give you a hyperbola. It would have an x distance of 4, a y distance of 5. In a hyperbola, we make the rectangle, draw in the diagonals, and then whichever one is first is the direction it opens. So there's our hyperbola, these two little things there. So again, not any calculus yet, that's coming up next, but just a little quick review on what a parametric equation is.